Welcome to EDU Aero classes. In this tutorial, we will discuss about what is determinant, what is singular matrix, and about minors and cofactors. Firstly, we will discuss what is determinant. Now, every square matrix can be associated to a number, which is known as determinant. Determinant is denoted by det of A or simply as this. For a of a matrix A. Now, first we will discuss determinant of a square matrix of order 1. That is, this is equal to A11 or mode of A11 is equal to A11. For example, if there is a matrix containing only single element. Suppose in a matrix there is only single element, that is 2. Here the order of the matrix is 1 by 1. Then so if we will find out the determinant of this matrix, this will come out. Suppose this is the matrix A and we have to find out the determinant of this. So this will be is equal to the element itself. Now, determinant of matrix square matrix of order 2. If we have to find out the determinant of matrix of order 2, then determinant of matrix A of order 2. Suppose there are elements in the matrix. This is the matrix of order 2 by 2. Now we have to find out the determinant. So first, multiply this element by this. That is 2 into 5. Subtract this into this. That is 3 into 4. Which will come out 10 minus 12 is equal to minus 2. Now we will see the determinant of a matrix of order 3. Now if we have to find out the determinant of matrix of order 3, that is 1, 1, 1, 2, 2, 2, 3, 3, 3. This is of the order 3 by 3. So firstly we will take intersection of both this element, that will come out this 1 into remaining matrix. कौन सी बची? 2, 2, 3, 3. Now minus intersection of first row and second column, which will come out this element 1 and the remaining matrix. Sorry, we will do it order 3 again. Now, suppose there is a matrix A is equal to 1, 1, 1, 2, 2, 2, 3, 3, 3 of order 3 by 3. And we have to find out the determinant of this matrix. Firstly, we will find out now we will expand this determinant along the first row. We will do now. If we are doing the expansion of the first row, firstly we will find out the common element of first row and first column, which is 1. That is this intersection this, which is 1. Now write out the remaining elements in the form of matrix, that is 2, 2, 3, 3. Now put out the minus sign. Then again we will find out the common element of first row and second column, which will come out this 1, and we will write out the remaining elements in the form of matrix 2, 2, 3, 3. Now we will add the common element of first row and third column, which is 1, and write out the remaining elements in the matrix form, that is 2, 2, 3, 3. Now we will solve this further 1 is equal into 2 into 3 minus 3 into 2. As we have already discussed how to solve a determinant of order 2. In the same way, we will solve this. Minus 3 into 2 plus 1 into 2 into 3 minus 2 into 3 is equal to 1 into 6 minus 6 into 0 minus 1. 6 minus 6, 0 plus 1 into 6 minus 6, 0 is equal to 0. So, determinant of matrix A is equal to 0. Till now, we have seen the expansion along the first row. Now, if we have to expand along any row or any column, we will do it like now. Consider matrix A having the following: A11, A12, A13, A21, A22, A23, A31, A32, A33, which is of the order 3 by 3. Now, if we have to find out its determinant along any row or column, what we will do? Firstly, we'll find out the common element and multiply it by the minus 1 की power I plus j. Now, if we have to expand this along second row, what we will do? Determinant of A will is equal to A21 multiplied by minus 1 की power 2 plus 1, because here I is equal to 1 and j is equal I is equal to 2 and j is equal to 1, and matrix remaining elements of the matrix will be A12, A13, A32 and A33 plus minus 1 की power 2 plus 2. Now we are finding along second row and second column, which will come out A22, common element is A22 and remaining element is A11, A13, A31, A33 plus minus 1 की power 2 plus 3, second row, third column. Here the common element is A23 and remaining element is A11, A12, A31 and A32. This is a generalized way of finding the determinant of order 3 along the second row. Similarly, we can expand the determinant along any row and any column. Now let us see this through an example. Here in this example, it is given D is equal to this and we have to expand this along second row. So here determinant D will be equal to what will become? Common element minus 1 power minus 1 की power 2 plus 1 means second row first column. Common element is 2 and remaining element is common element is 1 and the remaining element is 3 minus 2 1 and minus 3 plus minus 1 की power second row plus second column into common element is 2, remaining element is 2 minus 2 and minus 3 plus minus 1 की power second row third column, that is I is equal to 2 and j is equal to 3 into common element is 3 and remaining element is 2, 3, minus 2 and 1. We will solve this equation and get minus 1 की power 3 will come out minus 1 into minus 9 minus into minus 2 into 1 plus minus 1 की power 4 means 1 into 2 into minus 6 minus 4 plus minus 1 की power 5 means 1 into 3 into 2 minus of minus 6, which will come out minus 1 into minus 9 plus 2 minus 7 plus 2 into minus 6 minus 4, that is minus 10, plus 3 into 2 plus 6, that is 8, is equal to 7 minus 20 plus 24. 20, sorry, here minus 1 will come out. So it will be minus, and here also it will be minus. So answer will be minus 37. Here the point to be noted is that only square matrix can have determinants. No other matrix can have determinants. Now second topic is singular matrix. Singular matrix is a matrix whose determinant is equal to 0. If A is a matrix of order n, then it is a singular matrix if we find out its determinant and it will come out to 0, then it is said to be a singular matrix. Okay. Let's consider an example to understand this concept. Here, in this question, it is given that A is a matrix of order 3 by 3, and we have to check out whether it is singular matrix or non-singular matrix. It will be single matrix if its determinant will be equal to 0, and non-singular if its determinant is not equal to 0. We will find out its determinants and expand by expanding it along first row. If we will expand it along first row, then it will be minus 1 the power 1 plus 1, common element is 1, remaining element will be 2, 1, 2, minus 3, plus minus 1 की power first row second column, that is 2, 1 plus 2 into common element is minus 2, and the remaining element is 1, 1, minus 1 and minus 2, plus minus 1 की power 1 plus 3 into common element, that is 3, and remaining element 1, 2, minus 1, 2. This will come out minus 1 की power 2 is equal to 1 into 1. This is equal to minus 6 minus 2, plus minus 1 की power 3 will be equal to minus 1 into minus 2 is equal to minus 3 minus of minus 1, plus minus 1 की power 4 will become out 1 into 3. This will be 2 minus of minus 2 is equal to 1 into minus 8. Minus 1 into minus 2 is equal to 2, plus 2 into minus 3 plus 1 is minus 2, plus 3 into 2 plus 2 is equal to 4. This is equal to minus 2 minus 4 plus 12 is equal to 0. Since determinant of A is equal to 0, hence A is singular matrix. Minus. Now we will see minus. Minus of an element of a square matrix A is denoted by M of I, where I denotes the ith row and J denotes the jth column, where I is row and J is column. Now, if A is a matrix of order 2, suppose this is a matrix, this is the matrix of order 2, and we have to find out the minor of its element. Then M of 1 1 will be equal to this intersection this remaining element in the determinant form, that is this is equal to 4. M of 1 2 will be 1 2 3 4, means first row and second column, that is this one, is equal to 3. If you have to find M13, then first row 1 2 3 4. Sorry, if you have to find 2 1, second row and first column, this will come out. Then if we have to find 2 2, 1 2 3 4, second row and second column, this will come out 1. More determinant of 1, which will be equal to 1. Now let us see to an example. In this question, it is given there is a matrix A of order 3 by 3 and we have to find out its minor. First, we will find out the minor of element M11, means first row of first column. This will be 2 minus 1 minus 4 3, which come out 6 minus minus 4 into minus 1, which is equivalent to this minus 4 is equal to 2. Now, M of 1 2 will be equal to minus 3 minus 1 2 3, which is equivalent to minus 9 minus 2 into minus 1, which is equal to minus 9 plus 2 is equal to minus 7. M of 1 3 is equal to first row, that is first row and third column, 3 2 2 minus. This is equal to minus 12 minus 4. This will come out minus. This is 3. This will also be minus 3. This will become positive. This will come out 8. Now, M of 2 1 will be 2 3 minus 4 and 3, which will equal to 6 minus of minus 12, which is equal to 18. M of 2 2 is equal to 1 3 2 3 is equal to 3 minus 6, which will come out minus 3. M of 3 1 is equal to 1 2 minus 3. This will come out 2 minus of minus 6 is equal to 3. M of 3 2 is equal to 1 3 minus 3 minus 1 is equal to minus 1 minus minus 9 is equal to minus 1 plus 9, which is 8. M of 3 3 is equal to 1 2 minus 3 2. This is equal to 2 minus of minus 3 into 2, which is equal to 2 minus into minus 6 is equal to 8. This is our answer. We have all the minors of all the elements in the given matrix. Next is cofactor. Cofactor of an element of a square matrix, which is denoted by Cij, where I denote the row and j denote the column, is equivalent to minus 1 की power I plus j into m of ij, where m of ij is minor of that element, or we can say that Cij is equal to m of ij if I plus j is even, and minus of m of ij if I plus j is 4. Let's see through an example. Here in this example, we have to find out the cofactors of A, where A is a matrix of order 2 by 2. Now, we will find out the cofactors. Now, firstly, C11. C11 is equal to minus 1 की power I plus j. I is here 1. Also, j is 1 into m of 1, 1, which is equal to minus 1 into m of 1, 1 is 4, which comes out to be minus 4. Similarly, C12 is equal to minus 1 की power 1 plus 2 into m of 1, 2 is equal to minus 1 into m of 1, 2, means first is equal to 3, which will come out to be 3. This will be 1, positive 1, not negative. Yes, 2, 1, minus 1 की power 2 plus 1 m of 2, 1, which is equal to minus 1 into m of 2, 1 is 2 minus 2. C of 2, 2 is equal to minus 1 की power 2 plus 2 into m2, 2, which is come out 1 into m of 2 into 2, 1 is equal to. So the cofactors of a matrix A are this, this,